Hey, good morning. Back with you here. We're going to take a look at more organelles today. So we are in Unit 6. We're looking at everything inside the cell. And today we're going to focus on organelles that are involved with proteins. So a lot of what cells do revolves around proteins. Building proteins or sending proteins out. Proteins make up a lot of the components in the cell. So there are a lot of organelles and a lot of a cell's functions are based around, in one way or another, making proteins. We'll start off with hopefully what's a familiar image to you guys. This is going to be the nucleus. These are nuclear pores, these holes, and we're going to have a piece of mRNA coming out of the nucleus. So there's our mRNA coming out of the nucleus. Remember, not a whole lot of stuff comes into or goes out of the nucleus, but mRNA will. That's the copy of the DNA that we're going to eventually translate into protein. And really it has two options. Hopefully recognizing this. And these. Which is kind of the name of the game today. These are proteins here. This is our ribosome. So a ribosome is reading the proteins, or I'm sorry, reading the mRNA strand that came out of the nucleus, and it's translating it into proteins. Now I'm going to give myself just a little bit more room here. Come over here, about halfway across the page to take my notes, because we're going to go down this side with some drawings as well. So I'm going to come about halfway across the page. So I'm going to try and add a little bit of color to the drawing here. So here's the proteins. Underline this with that same color blue. Here's the mRNA, kind of made that a brown color. But the ribosome is kind of this greenish shade here. The nucleus is in purple. Well, I didn't put a note down for them, but make these nuclear pores yellow. All right, excellent. So we really have two different types of ribosomes. the one we've drawn so far is a free-floating ribosome, which is kind of off by itself, pretty much anywhere in the cell, anywhere in the cytoplasm of the cell. You need proteins made, this guy's going to be around to make them. Or, though, there's a second option. So here's our ribosome again. There's our proteins, the right color. This time, this ribosome is embedded to the rough endoplasmic reticulum, the rough ER. So they can either be free floating, just out in the middle of nowhere doing whatever, making proteins wherever it is proteins need to be made, or they're embedded in what's called the rough endoplasmic reticulum, the rough ER. In fact, that's why it's called rough. It would have ribosomes just kind of studded all over it. So if you ran your finger along it, it would feel rough, almost like braille, I like to think. Rough ER, his job is to provide optimal conditions. Remember, this is a membrane-bound organelle. Now it looks like it's opened over here, but really, if we continued off the page, it would actually be continuous with the nuclear envelope. Probably should have made it purple, but it is a different organelle. So I made it a different color. And what the rough ER does, it provides kind of a little area where we can have a different pH or a different temperature or very specific conditions for protein synthesis. If you guys remember a couple of chapters ago, we talked about some proteins are really need a high temperature or really low temperature or a high pH or low pH. And our entire cell can't have this huge temperature or this really low pH. So we just have this one little corner, this one little area of the rough ER. Inside of there, that one little room of the cell, we do make it a low pH or a high pH or a high temperature, low temperature. And so these proteins get made there in their optimal area. In addition to that, proteins can also be synthesized right into the membrane. And I thought it was a mistake here that I made this protein kind of overlapping the red line. It was not a mistake. I did that on purpose. We just did our chapter on the cell surface when there was a lot of proteins on the cell surface, on the membrane. How do they get there? Oftentimes, they're built there, back here in the rough ER. That kind of takes us to our next. So what can happen, or what often does happen, is that little area of the ER kind of buds off. So it kind of pinches off. There's my membrane-bound organelle there. So got all these guys traveling around. And you'd think that this should be red. It probably should be. It is the exact same membrane we're just working with, but it's a new organelle. This is what we call a vesicle. So this is a vesicle. And these vesicles are going to bud off from the ER. And they're going to travel to what we call the Golgi apparatus. Kind of looks like a stack of pancakes almost. Come back and finish that one just a second. We're actually going to do something very similar to what we're doing up at the top here. All right, so it's proteins, the vesicle kind of merges with the Golgi. And the face that it merges with is called the cis face. And what's going to happen at the Golgi is that these proteins get sorted and modified a little bit, and then finally repackaged and sent out in another vesicle to their final destination. So as they travel through the apparatus here, the Golgi apparatus, they're getting modified, they're getting sorted, different things being added. For instance, I don't know if you remember when we talked about proteins, proteins have 4 levels of folding, potentially. And that 4th level is when one polypeptide interacts with another polypeptide, like two proteins kind of that combine to make one large protein. Well, a lot of times that 4th level of folding might happen in the Golgi. You have these proteins here and maybe a different set of proteins from somewhere else that are all kind of merging. A little bit bigger. So all these proteins are kind of merging, and that kind of happens at the Golgi. Additionally, you might end up, again, you guys perhaps remember, hopefully you do remember, it hadn't been that long, we have glycoproteins. So those are proteins with carbohydrates on them. A lot of times that is going to happen at the Golgi as well. So there we've got a carbohydrate that's been placed onto that protein, and that happened there in the Golgi. So these proteins get sorted, they get modified a little bit. That Golgi is really a pretty busy spot for these proteins. And reemphasize what it is that Golgi is doing, I'm going to add just a little extra color. Again, they got modified a little bit. So now they got a little pink on them. These proteins do as well before they get sent out. There's our carbohydrate. Look, these proteins are arriving at their final destination. Got too many colors out. In this case, that final destination is none other than the cell membrane. So vesicles are going to again pinch off from the back end of the Golgi. Now that those proteins have been modified, this is known as the transphase. That's 2 words. add one more part to this. All right, that's it. We're out of room. I'm going to call it perfect, but just a little bit too much. But we're going to have these proteins leave the Golgi again. They leave from what's called the trans phase. And they're going to, again, it's going to pinch off in a vesicle, just like we saw before from leaving the ER. And that vesicle, which is made up of a phospholipid membrane, is going to join up with the cell membrane, and it's going to just kind of push those proteins out. They can go out into the world beyond the cell and do what they need to do. Or in the case of the membrane-bound organelle, guess what? Now he is embedded in the membrane on the outside of the cell there. So he can do his job. These guys can go do their job. And there we go. There are a lot of the organelles that are involved with proteins. Got the cell membrane, the transphase, and cisphase of the Golgi apparatus. Got these transport vesicles that take the proteins from one area to another. The rough ER, which has ribosomes, but ribosomes can also be free-floating. The mRNA is a copy of the DNA that comes out of the nucleus, specifically out of nuclear pores. So that's kind of in a nutshell what's going on inside of all your cells all the time with proteins. All right. Well, hopefully that worked out for you. Hope my picture wasn't in the way there. Let me know if it was, and let's take a picture of the notes here. But otherwise, I'll see you tomorrow for one more new lesson. All right. See you then.